Good afternoon, dear students. On the previous lesson, uh, we had so the previous lesson was about plane in the space, and our topic for today is straight line in the space, so in 3D. And now let me remind you some information, some theory. So the canonical equation of a straight line, so where point M with coordinates x0, y0, z0 is a point that belongs straight line L. M and P, M, N, and P are coordinates of the direction vector. It is the vector which either belongs parallel the straight line L or parallel to it. So then next from equation of a straight line passing through 2 points. So you know already that 2 points always, so we can so only one straight line can pass through 2 points. And so that's why we can write down the equation with known coordinate of 2 points, and as you can see, it can be reduced to the canonical form. Parametric equation of a straight line. So we can receive it from the canonical equation. So it depends on a parameter that is a real number. It will be useful in some tasks. So this is the general equation of a straight line. You know that so we have two non-parallel planes, and we know that planes that are non-parallel, they intersect by the straight line. So how can we get it? And here is the equation of straight line that defines bundle of planes passing through the straight line. So this parameter lambda is a real number. Then condition of straight line parallelism. So coordinates of direction vectors are proportional for both lines. Then perpendicularity condition. So straight lines are perpendicular if scalar product of their direction vector is 0. And the angle between the straight lines is calculated by the next formula. So cosine of the angle, by the way. So we divide scalar product of direction vector by the product of direction vectors magnitudes. And how to find distance between point M and straight. So distance between a point M0 that belongs straight line L and the point so and other point that belongs L. Yeah, so point M doesn't belong a straight line L, and point A belongs. So we need to divide magnitude of cross product of direction vector and vector AM0 by the magnitude of direction vector. And so condition for lines line in the same plane. So mixed product of so vectors, so the direction vectors and vectors based on the points line on each line, so they're coplanar, so their mixed product is 0. And if they are not on the same plane, if they are skew, so their mixed product is non-zero. And here is the formula of the distance between two skew straight lines. We divide magnitude of mixed product mixed product of direction vectors and vector based on points, and then dividing it by the magnitude of vector product of cross product of direction vectors. Any questions about theory? No questions. If not, we will move to tasks, to the practical part. And I guess no questions. Okay, so first of all, we need to we need to reduce the general equation of the straight line to the canonical form. So how to do it? Do you remember or not? If not, I will remind you. So how to solve? We need to set one of coordinates. So we need to solve this system of these equations. But first of all, we need to set one of coordinates as 0. So let's assign x equal to 0. And what will we have? Y applied to z equals 3, and 2y minus z equals 1. And we need to solve these equations, the system of these equations. So z equals 2y minus 1. So okay. minus 1 minus y plus 2y minus 1. I just substituting. So it equals 3. So now let's expand. Minus y plus 4y minus 2 equals 3. So so 3y equals 5. And y equals 5 third. So z equals, so 10 by 3 minus 1, it equals 7 third. So we found the point that belongs straight line L. What else we need? We need to find the direction vector. How to find direction vector? We can find it as a cross product of normal vectors of a cross product of normal vectors of these planes. So 2 minus 1, 2. 1, 2 minus 1. And it equals, so I plus 2j and plus 4k minus minus k plus 4i minus 2j. Let's double check. So I plus 2j plus 4k and minus before brackets. So minus k plus 4i minus 2j. So let's expand. So minus 3i, then plus 4j, and plus 5k. So minus 3, 4, 5. So the canonical equation is the following. So x by minus 3. Yeah, let's write it down the point M coordinates. So for better understanding what is happening. So M with coordinates 0, 5 third, yeah, so minus 4. Yes, something is incorrect here. Incorrect here, by the way. Yeah, so confused minuses. Okay, now we'll correct it. So 7/3, and we have a direction vector. So the canonical form of the line L. So x by minus 3 plus oh no equals y minus 5/3 by 4 equals z minus 7/3 by 5. So this is the canonical equation. And how to find projections? The projections on coordinate planes, basically. So x, o, z, x, o, y, y, o, z. So we will have three equations. How to receive them? We just take such equations, so separately. So this is the equation of projection on XOY plane. And this is the projection on, yeah, let's move it to the bottom. This is the projection on X O Z plane. And this equation is equation of projection of projection on YOZ plane. So you remember the equation of the straight line on a plane. So basically, these are equations of coordinate of the straight line on a plane in 2D. So we can, of course, reduce it, but no, let's not waste time. So it is here. It can be found here. So now, maybe you have some questions about this task.
Can you scroll up, please? And you just reduce x or you multiply something by 2, yes?
Here,
Yes.
well, I set x coordinate as 0, and then yeah, and then just so what remains this part of equation. So this part, what remains, and then I solve just these two equations.
And how you write the matrix?
Matrix.
That. Yes.
So I just took these two equations. I even don't use the matrix here. I just use substitution known from the school. So
No, a bit lower. You wrote a mix.
This you mean
Yes.
so determinant. Yeah, so basically that's a cross product of vectors n1 and n2, normal vectors. Yeah, so that's it, basically. Have I answered your question?
I forgot that the normal vectors are.
Okay, let me draw it. So normal vectors. Um, so two planes. And they are intersecting by uh, straight line and straight line. So yeah, normal vector is a vector that is perpendicular to the plane. So n1 for p1 and n2 for p2. And this is the direction vector that is either parallel or uh, beyond the straight line. So as you can see from this picture, so vector S is perpendicular to both n1 and n2. So have I answered your question?
Yes, where we get these normal vectors?
Normal vectors are received from equations of these two planes. So general equation of the straight line is equation. So we have two equations of planes intersecting by this straight line. So this is the first plane with normal vector 2, minus 1, 2. And the second plane with normal vector 1, 2, minus 1.
Okay, I understand something.
More questions? Okay, if no questions, moving next. So erasing everything here. So the next task is to write down equation of a straight line. Uh, so based on intersection of point P1 with equation with the following equation and point 2 passing through OZ axis and point K. So we have the equation of the first plane. We need to find equation of the plane P2. So how to do it? So first of all, we need to find, so yeah, we have one point K, but we also know that plane, for example, yeah, how it's named? Oh yeah, here it's named N. So so point N that is aligned, so that belongs the plane P2. So because because it intersects all z axis, so it has such a plane. And then let's write the general equation of plane P2 currently without knowing coefficients. Well, the general equation. So A2x plus B2y plus CZ plus D. Oh, yeah, D2 Z D2. It's C2 Z D2 equals 0. And now let's substitute n into this equation. So 0 A2 plus 0 B2 plus C2 z plus d plus d2 equals 0. So basically, what do we have? So we know that, so from this equation we can figure out that d2 is equal to 0. And then equation of P2 can be simplified. Let me erase a little bit. So coefficient d is free member is equal to 0. And now what we have to do, we need to substitute k into this equation. And then we will find coefficients. So for a1 plus 3b2 minus plus 2 c2 equals 0. So we found the bundle of planes. And now we need to find the coefficients. How to do it? We can just select. So we can just choose the convenient values. And now let's do it. So for example, let's assign assign to a value a2 equal 1. b2 will be so assigning 0 because of coefficient 3 is not convenient. So to avoid inconvenient fractions. And c, let's assign -2. So finally p2, so we have x -2 z equals 0. So, and that's it. If we substitute k, so 4 minus 2 by 2 equals 0. So k belongs p2, and it means that we found the equation of general equation of L. So 2x, let me just copy and paste it. And this. So what? So that's the final equation. So general equation of L. Any questions about this task?
So we just
No.
put our imagined numbers, except of coefficients, yes?
What do you mean? Imagine numbers, no, only real, or what do you mean?
No, I
Ah,
mean, мы их просто підбором.
підібрали. Yeah. So it's legal to do it in such tasks. So more questions? Okay, no questions. So the following task is to transform the canonical equation to parametric form. If we look at the canonical equation, so we basically have everything to transform. So we have a point M with the coordinates -1, -4, 3, and we have direction vectors, so we can rewrite to this parametric form. Basically everything, so we equals t. So it will be more convenient for you. So x minus 1 by 5 equals y plus 4 by minus 2 equals z minus 3 by minus 3 and and it equals t. So, and we need to resolve it with respect to t. So x plus 1 equals 5t. So x equals 5t minus 1. Oh, yeah. So even we can just look at this equation or transform this. So 5t minus 1, y equals minus 2t minus 4, and z equals minus 3t plus 3. And so that's just a parametric equation. Any questions about this task?
No.
Yeah, quite quick, quite easy. Okay, and now task number 4. So it's quite big, but we will solve it. So we have the canonical. So we have to write down the canonical equations of straight line L passing through the point M0 in different cases. So in the case of A, so it's parallel to vector S with coordinates 2, minus 3, 5. So how to solve it? Any ideas? So do we have everything for it or not? Maxim?
I think we have everything for it. So direction vector and the point M.
Correct. So yeah, let's just write canonical equation. So x minus 2 by 2 equals y by minus 3 equals z plus 3 by 5. And that's it. Then the next point, so we need to to write an equation of line parallel to straight line L1 with such equation. So what do we need to use here? So Maxim, yeah?
We need to substitute from the straight line the direction vector, and it will be equal to the direction vector for the line that we are searching for.
Yeah, so basically that's a direction vector of this line. So 5, 2, minus 1. And we have as well everything to write down the equation. But so what we change here only coordinates of the vector. So 5, 2, minus 1. Okay, and now C. So it's parallel to axis OZ. What will be direction vector if it's parallel to OX? Well, direction vector will be the unit vector corresponding x-axis, so vector I. And let's write it down. So x minus 2 by 1 equals y by 0 equals z plus 3 by 0. It doesn't mean that we have to divide by 0. It just means that the line doesn't depend on y and z. So y and z are constant always. But x is changing. So analogically to OZ, so what will be direction vector of the straight line? Daniel?
Unit vector of OY.
No, OZ.
Or unit vector of OZ.
So K.
Yes. 0, 0, 1.
Yeah, 0, 0, 1. And just to save our time, I will only copy and paste this equation and provide some changes. Okay, so the next E. So we need to find the straight, so equation. So we need to write down equation of the straight line that is parallel to straight line L2 given with 2 planes. Intersection of 2 planes. So what we need? How to solve? Who can remind me? Daniel?
I think we need to set one coordinate to 0. Like in previous task, we set x to 0.
No, we don't need it because we already have a point M that belongs straight line L, but we need to find the direction vector. And how to find it? Okay, who else? Maxim?
We can find it by cross product of
Yeah,
two direction vectors.
cross product of normal vectors. So that's it. Yeah, so let's find the cross product first of all, n1 by n2. So 3 minus 1, 2. 1, 3 minus 2. So 2i plus 2j plus 9k and minus k plus 6i and minus 6j. So I minus 4i and then j plus 8j plus 10k. Now let me check if everything is calculated correctly. Here is calculated incorrectly. Mistaken with signs. So what we have? Minus 4, 8, 10. And we can move 2 out of brackets. So 2 by minus 2, 4, 5. So as the direction vector, we will take a vector with coordinates -2, 4, and 5. The equation of a straight line L is the following. Let me copy and paste it again. Mhm. So x -2 by -2, y by 4, z by +3 by 5. Okay, and then what we need to find to write down equation of the straight line parallel to straight line L3 that is given with the parametric form. So what is which are coordinates of direction vector? Who can answer? Maxim?
It is 1, 2, and 1/2.
1, 2, and -1/2.
Yeah, -1/2.
Attentively with the signs, be careful. So, yeah, correct. And yeah, by the way, we can also avoid fractions. Oh, okay, let's write it just in this way, in this form. So, also modifying it. So here is 1, 2, and -1 second. So any questions about this task or no questions?
But why z +3? Ah, because we put pointer. Okay, understand.
Yeah. So z +3, right? Why? Yeah, because such coordinates. More questions? Okay, if no questions, let's move next. Solve 1 or 2 tasks, and we will have a break. So, task is the next. We need to write down the equation of straight line L passing through 2 points. So, which equation are you going to choose? The new?
Second equation.
Yeah, so this form, yeah. We know coordinates of 2 points. So x -1 by 3 -1 equals y +2 by 1 +2. And it equals z -1 by -1 -1. And if we simplify it, we will get a canonical equation of a straight line. So x -1 by 2, y +2 by 3, and z -1 by -2. So any questions about this task? As I see, no questions. Okay. So let's see if we can solve it quickly. So straight line that passes through point K and belongs L1. Okay. So let's do it. So task number 6. So how to solve it? What your ideas? So we already have a point and what we need else. So either second point or direction vector. What can we also we have point K, and what can we else find? So we know that point K belongs this straight line. So what else can we use? Any ideas? Yeah, Daniel?
We need to find point from this from L1 from L1.
Yeah, and how to find it easily, quickly?
Підставити. Ну,
It's even more simpler, more simple. Basically, we can find the coordinates from the equation. So, -3 is 0 and 6. So these are coordinates of the point that belongs plane L1. And we know that points K and M belong straight line L. So let's write it. So analogically to task 5, but yeah, the second point is not obvious. Okay, so x no, x minus 2 and x plus 2 and minus 2 divided by minus 2 minus 3 plus 2 equals y minus 5 by 0 minus 5. And z minus 3 by 6 minus 3. So the canonical form x plus 2 by minus 1 equals y minus 5 by minus 5, and it equals z minus 6, or z minus 3 by 3. Any questions about this task? Or no questions?
No.
Okay, if no questions, let's have a break for 5 minutes, and then we will continue solving tasks. Okay, let's continue. Let me minimize Zoom, let me share my screen. So the next task is to find an intersection point and a plane. Okay, I will explain you how to solve it. So how to find it? Well, to find intersection point of the plane and straight line, we need to solve a system of equations. So we need I will explain how to do it. So we need to transform a canonical equation of the straight line L to parametric form, and then we'll substitute into this plane, into the plane equation, so parametric form of coordinates. Okay, let me comment it during the solution. So let me paste it without changes. So this part separately, this and this. So it equals t. It equals t as well. And this part equals t as well. So now we resolve these three equations relative to t. Oh, no, relative to x, y, z, and we will receive t. So, without changes for now, so x equals t plus 1, y equals minus 2t minus 1. Z equals 60. And now substituting x, y, and z into this equation of the plane. So 2 by t plus 1 plus 3 by minus 2t minus 1 plus 6t minus 1 equals 0. And now let's solve it with the respect to t. Just find, solve a linear equation with respect to t. So 2t plus 2 minus 6t minus 3 plus 6t minus 1 equals 0. So reducing, eliminating 6t. So what we have 2t minus 1 minus 2. So 2t minus 2 equals 0. So t equals 1. Yeah, let me check. Yeah, t equals 1. So now with knowing parameter t, we know that we can identify intersection point of the plane and straight line. So coordinates x, y, and z. So x equals 2, y equals so minus 2 minus 1 minus 3, and z equals 6. So coordinates of point M are the following: 2, -3, and 6. And so basically that's a good example of usage of a parametric form of the equation of the straight line equation. Maybe you have some questions about this task, or no questions?
No questions.
Okay, if no questions, let's move next to the task number 8. So we need to find the angle between straight lines. So the formula is the following. So we just need to find the angle between their direction vectors. And that's it. So that you know already from the vector algebra. So first finding cosine, of course, of phi, and then we will see if we can calculate it. So 1 by 2. Okay, let's write in details. -4 by -2. Plus 1 by -1. And so 1 plus 16 plus 1. 4 plus 4 plus 1. Okay, it seems that convenient square roots. So let's write here. So 18 by 9. We don't need to multiply, so maybe something will be reduced. So 3 plus 8, so 11. Then 2 plus 8, 10, sorry. 10 minus 1, so 9. And we can move, so 9 by, oh, yeah, so 3 by square root of 18, and we can also move 9 here, so 1 by square root of 2. So, and so phi equals p by 4. So it is a table value. Any questions about this task?
No questions.
Okay, no questions, so let's move next. Task 8. Okay, task 9, we need to verify that straight lines L1 and L2 are perpendicular. So, what do you remember how to check if straight lines are perpendicular?
If their cross product is equals to 0.
Not cross product, scalar product of direction vectors is 0. Basically, it means that direction vectors are perpendicular. Okay, so the first direction vector, so which coordinates does it have? Daniel?
2 minus 1 and 0.
Okay, 2 minus 1, 0. And for the second? So we
1
can...
to 4.
Yeah, 1, 2, 4. So yeah, we can find it from parametric equation. 1, 2, 4. So we don't have to do anything with these equations. We can easily find direction vectors from them. So yeah, multiplying vectors s1 and s2. So 2 by 1 minus 1 by 2 plus 0 by 4. And we can see that 2 minus 2 equals 0. So, but the final answer is to also to write down that we had to verify that so that lines L1 and L2 are perpendicular. That was required to verify. So this is the final answer. Not to calculate scalar product, but to prove that perpendicular. Any questions about this task? So, no questions, as I see. Okay, now let's move to the task number 10. So, what do we have here? We have a project, so we have equation of a straight line and point M that just point M with the given coordinates, they are known. So, firstly, we need to find a projection of point M. Let we call it N. So that's it will be projection of point M on a straight line L. So firstly, how to find it? We need to so projection of point M will be the will be intersection point of straight line L, and the plane is that is perpendicular to L. So first of all, let's find projection of the point N will be the point that belongs plane P perpendicular to a straight line L. So first of all, we need to find plane that is perpendicular to L, and also M belongs P. If I'm not mistaken, yeah, it belongs point P, plane P. So how to find the plane P? How to find the normal vector? We have the point, we need also normal vector. Any ideas? So plane P and straight line L are perpendicular. So
The scalar product equals to 0.
well, basically not. So what's simpler? Not equal to 0. So let me draw. So the plane P and point L. So L, P, and their intersection point. So this is the direction vector of straight line L. So how can we find the normal vector of plane P? So the idea, so what does normal vector mean? What do you remember about it? Daniel?
It's perpendicular to our plane, so our line L is normal vector to P plane.
Oh, direction vector
direction.
yeah, direction vector of straight line L equals to the normal vector of plane P. So it has coordinates 2, -1, and -1. 2, -1, and 1. Sorry. Okay, and now let's write the equation of the plane P. So 2x, let me copy this point. 2 by x, 2x minus y minus 1 plus z minus 2. And it equals 0. And now let's expand. 2x minus y plus z, so 1 minus 2, so -1 equals 0. So this is the general equation of plane P. And yeah, let's check that, yeah, everything is correct. And now we're doing the same that we were doing before. We need to find the intersection point of plane P and straight line L. So we need to go, so we need to transfer to parametric equation of L. So x, okay, let me copy and paste it. Just for our convenience. That equals t, and this equals t as well. So x equals 2t plus 1.5. Y equals minus t. Z equals t plus 2. And now let's substitute to equation of plane P. So 2 by 2t plus 1.5 plus t plus 2 and minus 1 equals 0. And now let's find, let's expand first of all. So 4t plus t plus t, so 6t. So 3 plus 2, 5 minus 1, 4. So 6t plus 4 equals 0. So 6t equals minus 4. And t equals minus 2 seconds. So found the parameter, let's verify it. Yeah, so minus 2 seconds. And now we need to find, so substituting, so x equals, so minus 4. Okay, so what we not waste our time with calculating fractions. But no, we have enough time, so let's do it. Well, so we calculate this fraction, so x, so minus 4 by 3 plus 3 second, so it equals, so 9 minus 8, so 1/6. Then y equals 2 seconds. And z equals, so So 6 third minus 2 second, so it equals so minus 2 third, so it equals 4 by 3. So here are coordinates. Here it's named k, but we already named n, but never mind. So projection of point M has coordinates 1 by 6, 2 by 3, and 4 by 3. So any questions about this task, about part A?
No questions.
Okay, no questions. And other section is to find point M prime symmetric to point M. So relative to the straight line L. Okay, now let me draw it. So how it should look like. So we have straight line L. Also what we have, point M. And we have a projection of this point K. Okay, point N, let it be. And we need to find M prime. That is symmetric to point M relative to straight line L. So, ideas how to solve. Yeah, I know it's not quite symmetric on the drawing, but the idea. Daniel?
I think we can find length to n, mn, and then we can find nm1. Oh, n is center, and
Yeah.
m1 and mm1 is all length. So we can from formula we can find m prime, where x1 minus x2 divided by 2 equals nx.
Yeah, so that's just middle of so middle point between these two so between M and M prime. So x M prime can be so found by the following formula. So 2xn minus xm. So 1/3 minus 0, so it's just 1/3. Analogically to y, for third minus 1, so it equals 1/3. And z for m prime equals 2 zn minus zm, and it equals so 8/3 minus 2, and it equals 2/3. So the coordinates of the point M prime, so 1/3, 1/3, and 2/3. Let's check here. Yeah, so everything is matching. So any questions about this task? About the lesson, about previous lesson, other questions?
When will be available all tasks?
Yeah, thank you for reminding. I will. So I won't forget to unlock it today. Yeah. So don't worry.
thank you.
The second group also have already asked me this question, so it increases chances not to forget. More questions?
А можете зачекати? Демонстрацію повернути.
Okay. Угу.
Там я вам хотів сказати, що спосіб, щоб швидше витирати Paint, ніби там можна натиснути на нього, нажати Ctrl-A і Delete. Ну, щоб не витирало все.
Дякую. Я хочу пошукати ще якісь більш зручні програмні засоби. До речі, якщо щось запропонуєте, буду вдячний. Щоб не писати так прописом. Okay, thank you for your advice. Yeah, so A, delete. Yeah, cool. So more questions, suggestions.
Yeah, I have one.
Mhm.
So can you allow to do all home tasks individual?
Yes, already somebody answered. Oh, maybe you. Yeah, so yeah.
Second and third too. Yeah.
Third, I'm not sure about it, but first of all, yeah, let's start with the second. Okay, more questions. Okay, as I see, no questions. So have a nice evening. Stay safe. Thank you for your attention, and goodbye.
Thank you.
Thank you.
Thank you. Goodbye.
Bye.
And for the lesson, goodbye.
Bye.